Alright, so now we're going to talk about EEG, which stands for Electroencephalography. The way that this technique works is that when a neuron is active, it becomes more positive, as you guys all remember, and that actually generates an electric field. And if a lot of neurons are activated and they're oriented in the same way, it generates a really big electric field that's so big, in fact, that you can record it, so pick up that signal from electrodes just placed on the head. So by doing this, we can tell when populations of neurons are active and a little bit about where they are. But the thing with EEG is that the signal is smeared a lot as it goes through the skull. So two electrodes next to each other will look very, very similar, and even two electrodes farther apart will look very similar, which we'll see in a second. So it's not so great for telling you where things are happening, but it's really good at saying when things are happening. So now that we have the cap set up, we're going to put it on Mr. Leader's head, and it just kind of goes on like a fancy swim cap. And you can see there's all these little holes, and that's where we're going to be plugging the electrodes. So we're going to try to get it. We're going to try to get it centered. And we're going to just do a couple quick measurements to make sure that the electrode that's supposed to be right in the center of his head is in the center. So there's the right distance forward and back and the right distance side to side. And so now we're going to start putting gel on all these holes. And the gel is so that we can get a good connection with the scalp so that we can actually record the activity. Because these signals are very small, so we want to make sure that we're able to pick them up with the electrodes. So what we do is we just kind of put a little bit of gel in all these holes, and you'll see when we're done that his hair is going to be pretty messy.
Feels cold.
So now we have that set up, and we're going to start plugging in all these electrodes into the holes on the cap. So you just kind of have to match up the letters to the labels on the cap. So you can see here's FP2 and FP2. Okay, so now we have Mr. Leader set up, and we have all these electrodes recording the activity of neurons in his brain. The signal goes through these cables to the amplifier, where it gets bigger, and then we actually send it to this computer over here. Alright, so now we have the data, and each of these lines is coming from one channel on Matt's head, so one of these channels. And you can see, first just notice that there's some, the channels that are near each other tend to look similar, so you can see like these two, which are both in the front of his head, over here, look very similar. And you can see there's a lot of high frequency noise, so like little bumps, which are related to the muscle activity of the muscles on his forehead. And down here, there's also some high frequency bumps, and that's because these are the same channels on the other side of his head. So that's why they look pretty similar. And so now we can look at a few other kinds of artifacts that you can see from the raw EEG. So first we can have Matt blink. You can see each of these bumps corresponds to a blink, and that's related to the positive polarity of the eye. So when someone blinks, the eye rolls up, and you can actually see this positive wave through all the channels, especially the ones in the front. So this is in the front on the left, and this is the front on the right. We can also look at muscle activity from the muscles on the side of his head right here, the temporal muscles. So Matt, could you please clench your teeth? You can see you get lots of high frequency muscle activity there. So when we do experiments, we try to have people relax their face as much as possible, because you can imagine that this noise is much harder to, it blocks any kind of noise from, it blocks the activity from the neuron, so you can't see it. It masks the activity. We can also try to look at eye movement side to side. So can you look side to side, Matt? You can see when he does that, you get sort of these big square waves. And that's related to the same kind of polarity of the eye, but now that it's moving side to side. What's hard to see in a single trial is actual brain activity, so that's why we normally average across many trials, because the noise from just his muscles and his eyes and other kind of noises in the room are much larger than the neural activity. So we normally average across many trials. But one kind of brain activity you can see in the raw signal like this is alpha waves. And alpha waves are associated with sort of a relaxed state, and you start to see them when people get sleepy and when they don't have visual input. So Matt's closing his eyes now, and you can see you're starting to get some alpha waves, lots of them right there. And so when you start seeing this when someone's doing an experiment, we sometimes try to tell them to wake up, maybe give them a soda or something. Alright, so now we're running an actual experiment with Mr. Leader. So as you can see, there's some squares and X's being presented on the screen, and he's responding with button presses to do this task. So he's when he sees certain combinations of squares, he will hit a button. And while this is happening, signals are being sent to the EEG, which are numbers, and the numbers mean different things. So when a blue square is presented, you might get a number 3, and when a white square is presented, you might get a number 4. And that way we can tell what his brain is doing when he sees certain things on the screen. So now that we've completed the experiment, we've removed all the electrodes, and we're ready to take off the cap. And you can see all the gel. Oh, it's not that bad. All the gel in Mr. Leader's hair. So this is the only sort of side effect of EEG, is that you have messy hair afterwards. But it's not so different than normal hair gel. So let's review what we've learned. EEG stands for Electroencephalography. This technique can be used to record brain activity because it detects voltage changes that occur due to neurons becoming active or firing. Some important things to remember about EEG is that it's very good at detecting when things are happening. So it's very fast at picking up changes in how neurons are firing. But it actually has very poor spatial resolution because of the smearing of the signal through the skull. So it's hard to tell where the activity is coming from.